So following on from the previous video, to work out the surface area of a solid, we would work out the arc length, which we know how to do from some of the earlier videos. We've done this many times. We know how to work out the arc length. Once you've got your arc length, then times it by the circumference. That will then sweep out the whole area here, and then you would sum up all the areas. Okay, so this arc length here corresponds to this. So this is our arc length here. Once we've got our arc length, then we would times it by the circumference. Okay, so we would then times it by the circumference. That would then, well, once you've got your arc length, times it by the circumference. But the thing is, which radius do you use in order to get the circumference? You see, this radius here. This radius here, which is this one here, is higher, is bigger than this radius here, which corresponds to this one here. So a fair way of doing it would be to use the average of the two. So hang on. So this radius here, which corresponds to this one here, is given by f of x k minus 1. So this is the radius here, okay? And then this short radius here is given by f of xk. But a fairer way, so that's this bit here. So a fairer way would be to use the average of the two radii here. So we don't know where it is. Let's just say it's somewhere around here. Okay, so we would use the average of the two. And then this average radius here, would be f of, let's say, ck. We don't know where this c is, but we know it's somewhere in between here and here. Okay, we know c of k is trapped somewhere in between the two. You see, and then this width here is delta x. As we make delta x heads towards 0, then you can see that that this here, which is the average of the two radii, will lie on top of fx here. So that's the whole basis of integration or of calculus. You see, you've got a tall radius here, and then you've got a short radius here. The whole basis of calculus, and it's the whole beauty of it all, is that, and it's something that a lot of people fail to understand, is that we've translated, we've got a tall radius, and then we've got a short radius. We would then translate this into the, well, we would somehow trap it somewhere in between the two. So we would then translate this into this. And because this is trapped somewhere in between the two, then as you make the width smaller and smaller, as you make delta x heads towards 0, then this thing here becomes f of x, and that's the whole basis of calculus, and it's something that a lot of people fail to see. Well, the whole basis here is that if you have something that's big, small, if you can somehow trap something in between the two, this here is really us using the mean value theorem. Somehow trap something in between the two, and then as you make this smaller and smaller, then this middle one will lie dead on top of f of x, and then we can use f of x. The whole basis of calculus is really you using the mean value theorem, is you somehow trapping something in between the two here, and then make this width smaller and smaller, and then this something that you're trapping in between the two will lie on top of f of x, and then you can use your f of x to do all your calculations. That's the whole basis of calculus, is to trap this middle thing in between the two, and that's you using the mean value theorem. And then you would combine the mean value theorem with the concept of limits, meaning make delta x tends to 0, And when you make this width here tends to 0, then 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 the average, this average height, this average radius here will, or whatever it may be, will lie on top of f of x, and that's the whole basis of calculus. Well, anyway, hang on. So this is our arc length here, and this is our circumference here. We would use this because when we set up the interval, hang on, xk minus 1, and then this is xk here, and our c of k is somewhere in between the two. By the way, this, for when we worked out the arc length, this c of k here would be different from this c of k here. So really, I should give it a different name. Let's put a pretty hat on it or whatever. Okay, so we would use this ck here to work out the arc length, and this ck here could slide back and forth. We don't know where, but we just know it exists in between the two. That would then give us the arc length, and then we would use this different ck here. This different ck here could be the same, or it could be different from this one here. But the point is that this ck here it also slides back and forth here, but it's always trapped in between the two. But then as you make delta x tends to 0, because we know that c of k is always trapped in between the two, then we know that ck will lie dead on top of x. So the minute you take the minute you use the concept of limits, then this ck here will become the x, and then this here will also become, well, once you start to take once you apply the concept of limits, meaning that no matter what level of tolerance someone gives you, you can guarantee, you are 100% sure you can get to within that level of tolerance. Okay, so it's really us applying the concept of limits. So once we've applied the concept of limits, then the surface area will be given by this. Okay, but what's important here is really you using the mean value theorem, you trapping something in between the two, and then make delta x head towards 0, and then your f of ck will lie dead on top of f of x, and then you can use f of x to do all your calculations. Okay, so the formula for the surface area is given by this. Okay.